Let's do some conversions. These are numbers 8 through 10 in the Chapter 8 practice problems. We're converting from binary to decimal to hexadecimal in pairs. So we have a binary number, and I know that because I have a subscript of 2, and I'm going to put that in decimal form. So if you review the material for this lesson 8.4 in that chapter, you're going to find that binary is a base 2. So we see here we have 2 to some power. And we know that the number is in binary form, so we got to put it into decimal, which I don't have written here at the end, but that would be a base 10. That's the one that we normally use. So each one of these digits has a place value. If I start with this, the number right next to the subscript, the 1, that's in the ones place, or 2 to the 0. Then this is the 2's place, and then the 4's and the 8's and the 16's. So we have 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and 2 to the fourth. All of these values that are being multiplied by zeros or have a 0 as a digit are just going to disappear, since I'm going to be adding a 0 to another number. And then all the other values, this 2 to the fourth we said was 16's, that's going to equal 16. And then here's the 2 to the second, which is going to be 4. And 2 to the 0, which is going to be 1. So we're just going to take 16 plus 4 plus 1, add them together, and we get 21. So this value in binary is equal to that 21. For numbers 9 and 10, you're going to refer to table 8.4.1, the hexadecimal digits and corresponding encodings in decimal and binary to do that one. So what we do is we take, in number 9, we take this value and we take the first 4 digits and kind of expand it out. And then this 1 doesn't have anything to the left, so those are just going to all be zeros. If you look on that table, you'll be able to clearly find those values. The 0001 is going to correspond to 1 in hexadecimal. And then the 0101 is going to correspond to 5. So we would just have 1, 5. Now notice I've written this in a couple of different ways. You can use the subscript 16, you can use the H to represent hexadecimal, or 0x15, which I use down here as well. So make sure that you know all these different ways. I will accept any of those ways, but if you're given something, you need to be able to figure out what it is. Like I said, 0xA3DF, well, that tells me it's hexadecimal because it's in that format, and I want to put it in binary. So now I just go the other way. I find the letter A, and I know in binary that's 1010. I found the 3, and that's 001. I find the D, and that is 1101. And then finally I find F, which would be all ones. And so that's going to be my value, and I just put the 2 as a subscript to show that this is a binary value.